Hello and welcome to Train Signal. This is video number 7, Administering Linux, Part 1. This is part of Fast Track CBT video series, Linux Networking and Administration. So in this video, we're going to talk about managing Linux processes, identifying processes and process trees, monitoring and troubleshooting network activity, manipulating text files, and redirecting output. So let's get started. First off, we're going to talk about managing Linux processes. Now, in Linux Plus Objective 2.11 and 2.12, they discuss Linux processes. 2.11 says, identify, execute, manage, and kill processes, for example, using these programs, ps, kill, kill all, bg, fg, jobs, nice, renice, and rc. 2.12 says, differentiate core processes from non-critical services. For example, init, kernel processes, PID, and parent PID values. So first off, what is a process? Well, a process is a running program. So any program running on your Linux system is a process. Okay, more than one process can be running at a time. So most Linux systems are going to have many processes going all at the same time. Now, one program can fork another program, or spawn a process, spawn a program. It's also called fork a program or fork a process. So you have one process, let's say your shell, the bash shell. You type ls, well, you just started another process called ls, and that process is the child of the bash shell. So when a process is forked, the original program is the parent program and the process forked is the child process. So that forked process runs, the ls runs, it lists out the files that are in that directory, and then it's done, and then that process is terminated and you're back at your bash shell. The bash shell never stopped, it was just busy forking the ls process that you told it to start. So this forms a process tree. So a process tree is one process forks another process, and say that process could fork two other processes, and one of those processes could fork another process. So you see how this tree kind of flows down. It's an inverted tree. It starts with the single process at the top. In this case, we talked about the bash shell was the single process at the top that forked multiple other processes, and then those processes can fork other processes. So at the very top of the process tree for the whole Linux server is the init process, stands for initialization. So the init process is the very first process in the whole process tree for any Linux server. So init is what forks all the other processes on the Linux server. It's the one that forks the process so you can log in, and then the process so you can start your bash shell, and then the bash shell you start other processes. So to see the process list in Linux, you type ps, stands for process list. Now by default, ps only shows your processes. If you just type ps, you'll get like two processes listed. Usually it's bash and the ps program that you just ran. But to see every process on a Linux server in full format, use ps-ef. So ps-e stands for every process, and f stands for full listing, which just means you get multiple columns, you get a lot of different information. Now to see the user of a process, use ps-u. Or you can put the u up here with ps-efu. So u shows the actual username who started the process. So if you just log in as root and you do a ps-efu, you'll see almost every process on the system is owned by root. There's a couple exceptions, I know, but almost every process is. Unless you have a Linux server that has multiple people logged into it, then you'll see the different user processes. Or if you log into a Linux server as yourself, of course you'll see your processes started by you. ps-ef capital H will show a process tree for all processes on the system. So that's a really cool command because you see the list of processes, and any process that has a child process, you see that child process kind of drawn out there. So we're going to be doing these commands here in just a second on our Linux server. But before we do that, let's finish the slide here. Now it says PS supports 3 types of options. They are Unix 98, BSD, and GNU Long. So Unix 98 are the types of process options I'm using up here, like PS-EF is a Unix 98 option. So Unix 98 is anytime you use a dash or minus in the option. There's the BSD options. In that case, you don't use a dash, like PS-AUX. Wait, I'm sorry, PS-AUX without the minus is a BSD option. So there's no dash, there's no minus in BSD options. Then there's GNU Long. Those options have 2 dashes, so like --help is a GNU Long option. And PS supports all 3 different options. Can be a little confusing, especially when you try to read the man page. And there's just so many different options because there's 3 different ways to do everything. Be familiar with the following on the PS output. Very important to be familiar with how to see the username, how to see the PID, how to see the parent PID, and how to see the TTY. So the PID is the unique ID number associated with every process on the system. And every process is going to have a parent PID, and that's going to be the unique ID number associated with the parent process. And then the TTY is what device that process is running on. So if you have dumb terminals on your systems like TTY 1, 2, 3, those are actually plugged into serial ports on the back of the system, you'll know exactly what terminal that's running on. But if people are telnetting into the system or connecting remotely like with SSH, then you have virtual TTYs, and these are called PTSs. They're virtual TTYs. Now top is a command to show what processes are using the most RAM. Make that bold there because that's important. Top is a process or a process PS option. So you basically run top and it runs a PS command that's very customized and shows you exactly what processes are using the most RAM. Top is a very cool program. We'll use that in just a second. Okay, the GNOME System Monitor is a graphic system monitoring utility. That's important too. Let's bold that. So GNOME System Monitor is a program that you can run at the command line, or it's actually in the menuing system. You can run this and it'll bring up a graphical system monitor. Very cool. We'll be running that in just a little bit. But you should know the name of that command there. Alright, so you got some processes going and now you want to get rid of them. How do you stop those processes? Well, you use the kill command. Kill works by process ID, so you have to know the process ID. So you type PS, you see the process running you want to kill, you type kill space and then the process ID number. That's how you kill processes using the kill command. Now kill all works by name. So you type kill all space ls or kill all space bash, and it'll kill all the bash shells if you type kill all space bash. If there's multiple, it'll prompt you. By default, it prompts you. Do you want to kill this one? Do you want to kill this one? But that's what kill all does. It's very handy if you know someone's running a program. You know it's a certain program name. Say it hangs periodically. You use the kill all command to kill it by name. You don't have to go look up the process ID number with kill all. Now say you want to put a process in the background so that you can have your shell running. You can change back and forth between a process that's running in the background and a process that's running in the foreground using the background and foreground commands. They're BG and FG. Now Control-Z pauses a program and the process is suspended. So say I'm running a long command, it's taking a long time to process, I need to go do something else. I hold down Control, I hit Z, it says process is suspended. I go do whatever it is I need to do, and then when I come back I type FG to move the process into the foreground. And you can have multiple suspended processes on a system, and you can actually use foreground and then a job number. You can type jobs to see what processes you have in the background. Now sometimes you'll want to run a process and give it more CPU or less CPU on the system. The command to do that is nice. You want to nice the process. So usually when you're nicing a process, you're giving it higher priority. And I think that's where the name comes from, nice. You're being nice to the process, giving it higher priority. Sometimes though you might want to give the process lower priority, and you can do that with nice as well. Now the nice program is used when launching a program. So whenever you start a new program and you want to give it higher or lower priority, you use nice, the priority you want to change, and then the process name. Now when you use the nice program, the default is 10. So if I just type nice space the name of the program, I'm giving it a niceness priority of 10. When you enter the number in, you're adjusting it from 10. So anytime you type in nice space and some number, you're adjusting it based on 10. So if I type in nice space 5, I'm adjusting it 10 plus 5, so that would be 15. If I type nice space -5, I'm moving it from 10 down to 5 by subtracting off the 5. Now renice is used after a program is already running. So the renice command will change the priority of a process once it's already started. Niceness priorities range from -20 to 19. Where negative values have the highest priority, that's important. So a negative process has a highest priority. So a -20 is the highest process priority you can have. So 10 is much lower than -20. 0 is much lower than -20. So that's pretty confusing to me, but it's something that you need to understand. -20 is the highest process priority. Don't ask me how they came up with that, but that's how it works. So any user may lower their program's priority, but only root can increase a program's priority. So anybody can make their process priority lower or closer to 19, but only root can up the process priority. Now the default program niceness is 0. So if I just run a program, the niceness is 0. So if I use the nice program and I start a program, its default is 10. So I'm actually not being very nice to the program by running it with the nice. So nice actually makes a process priority 10, which would be lower than the default, which is 0. Now PS-L will show you what process is running and at what priority. So PS-L will have a little column that says NI or nice, and that's the niceness value or the priority of the program. So you can see what other programs are running and what their priorities are. So with that, let's go check out the process tree. Let's go try out some of these commands. So I'm over here on our Linux server. I'm logged in as root. I'm going to start a terminal window. Maximize the screen. So let's start off by typing PS. So PS shows me what processes I'm running. So I can see the PID. I can see what TTY the processes are on. I'm not on a physical TTY. I'm on a pseudo terminal is what that is. The PTS is a pseudo terminal number 1. Anyone who telnets in or is on an Xterm or is on an SSH connection will be on a pseudo terminal. This is the time that the process has been in the CPU, not the actual time, human time since it's been running, but the time that it's been on the CPU. So usually this is just milliseconds or seconds. If a process has been running for weeks, it might be minutes. But it usually stays pretty low unless you have a very intensive process or a process that's been running a long time. Here's the actual command that was run. So I have a bash shell, and then I have a PS or process list, which you can see I just started. If I type PS-F, I get to see the user ID, or the user who owns these processes. Now I'm logged in as root, so that's me. I also get to see the parent PID, the parent of the process. So in the case of the PS-F, the parent was 2945, and then 2945 is bash. I get to see the CPU, the system time, the PTS again, CPU time, and the program. So the -F, the two biggest things for me that it does is it shows you the user and it shows you the parent PID. So now let's do PS-EF. Wow, that was a lot of processes. That was every process on the system. So to see these processes page by page, I do PS-EF and pipe that to more. So notice here that the very first process is a init. I said init is the initialization process. It's the process that starts all other processes on the system. And notice that the PID for init is 1. Init is always PID 1. So then PID 1 spawns other processes, like this process here and this one and so on. Any process here you see with a parent PID of 1 was spawned by init. Then those processes can in turn spawn other processes. For instance, here's PID 6, the K-thread process, and it spawned this process here, the K block D. Any process over here that starts with K, K helper, K thread, K block, K hub, you can see there's a lot of them. Those are kernel processes. Those are special system processes. I would not kill any process ever that that you see in this list right now, because these are all started by root and they were started when the system started. So if you want to actually stop one of these services, you need to find out how to properly stop it in the services application. If we scroll down here, you get to see all these different processes, the GNOME X Windows system. There's a lot of processes that make the system work. And finally, at the end, you get down to the processes that actually were started by me here in this shell. So that's PS-EF. Now PS-EFH shows us something a little bit different. Let's just look at the end of it right here. See this GNOME terminal? That's actually my terminal window. And then it spawned GNOME PTY helper. And I can tell that just by looking on the right side over here because of this little indentation. So that process spawned this process and the bash shell. And then the bash shell spawned PS-EFH. So you can see this little kind of process tree as it goes down, this little stair-step motion it does. And you can verify that with the parent PIDs over here. 2943 is the parent PID of 2944, the GNOME PTY helper, and 2943 is also the parent PID of bash. Then 2945 is the parent PID of PS-EFH, which is the bash shell. So if I type PS-EFH and I pipe that to more, you can see here's init, and then init spawned these processes, and the K-thread process spawned these, and then init spawned these, and then these, let's see, these were spawned by init too. So you kind of go down here, and like here's HALD program, which spawned this, and then HALD runner spawned these. So you can very quickly see with the PS-EFH the process tree, how these things tree out. One process spawns another process, and then that spawns another process. So PS-EFH is a very cool program. Let's run top. Okay, I said top shows you system memory in use by all processes, but it shows you a lot more than that. Top is sort of like PS taken to the next level. Top shows you how long the system's been up 2 days, 13 hours, and 9 minutes. There are 2 users logged in. Whoops. Quit out of there. Let's run top again. Okay, there's 2 users logged in. You can see the 2 users right there. Here's the average load on the system. It has 91 processes running, 1 running, or actually 91 total. 1 is actually running at a time, and 90 are sleeping or waiting. 0 stop processes, 0 zombie processes. 1% of the CPU is being used by user processes. 1.7 is used by system processes. 0 processes are nice, and 96% idle. So the system's pretty much sitting here idle. 0% is of the processes are waiting. Those would be waiting for CPU. There's some other parameters here. I mean, there's so much on this screen. You really have to go read the man page, and that could take you a little while to really learn every single process and feature and column that you can see with top. There's 256 megabytes of RAM on the system total. 249 megabytes of it is used. 6.2 megs are free. There's 79 megs in buffers. Swap is 524 megabytes. Only 96K of it is used, and 524 megabytes of swap is free. Over here on the column output, there's the PID numbers, user, there's the priority, here's the niceness. Like I said, there's a lot of different columns here. Percent CPU, time in CPU. So the XORed process has spent the most time in CPU. Here's the percent of CPU being utilized by that process and the percent of memory being utilized by that process. So to me, those are the most important columns right here, percent CPU and percent memory, because you can use top to determine if you have a process that's taking a lot of your CPU or a lot of your memory. So say a user calls and says, hey, the system's running real slow today. You can run top and you can see, well, what process is taking the most CPU and what's taking the most RAM. And maybe you need to investigate that process, restart it, kill it. It depends what the situation is. So to get out of top, you hit Q for quit. So that's top. Now let's start the GNOME System Monitor. You can type GNOME System Monitor from the command prompt, or you can actually just go up here to the System button, click Administration, and then go over and down to System Monitor. So System Monitor is kind of like a task manager in Windows. So let's start off, let's click Processes over here. You get to see all the processes on the system. You can quickly sort them. So here's process name, here's the status. You can click that and I can see that this is running. It's taking up 12 megabytes. Let me maximize this screen so you can see all the columns. 12 megabytes of RAM, CPU time, niceness, ID, security context, who's it running as, the arguments, load average for the last 1 minute, 5 minutes, 15 minutes is 0.12% CPU utilization, 0.10 and 0.14. So you can see kind of the trend over time here over the last 1, 5, and 15 minutes. How has the system been doing? Has it been getting harder, or have things been kind of slowing down for it? You can click on a process and you can end the process right here. Let's click on resources and you can see the CPU history. You can see a graph of it and a trend. Same thing for memory, same thing for network. If you click on one of these buttons here, you can change the color of one of the things that you're graphing. So a very cool little graphing system. If you click on devices, you can see what devices are on the system. These are really hard drives that you're thinking of when they talk about devices. So these are what hard drives are on the system, the type of file system, total amount of disk space, percent free, available, used, and you see a little chart over here. So System Monitor is a very cool graphical program for Linux. If you go up here to View, you can see active processes, dependencies, set preferences, things like that. So let's quit out of the GNOME System Monitor. And let me clear the screen. Okay, and now let's talk about kill and kill all. So I'm going to start a process here called sleep. There's a scripting function called sleep that you just tell it how many seconds you want to sleep. So I'm going to say 10,000, a lot of seconds. I'm going to put it in the background. It tells me it started up. I'm going to type PS. You can see there's sleep right there. It's sleeping, it's doing its thing. So say I want to kill sleep. I don't want it to run anymore. I type kill, and I type the process ID, 3015. And I just killed it. I type PS. It's gone out of the process list, and because it was in the background, it tells me that it terminated. If it was on someone else's system, I wouldn't get that message. But I could still see it in the process list, of course. So that's how kill works. Pretty simple. You type in the process ID, you kill the process. Now let's start sleep again, and this time we're going to use kill all. I'm going to type kill all space sleep. And seems like it did its thing. Sure enough, sleep is terminated. So because there was only one sleep process and it had the exact name of sleep, it killed it and it's gone. So kill all works by name, kill works by process ID. Alright, let's run sleep again. And let's type jobs. Okay, the jobs command tells me I have one running process in the background. It's job number 1. That's what this number 1 is over here, and here's the process. So if I type FG or foreground, it puts sleep in the foreground. Now I can't see the, sleep just sits there and sleeps. That's all it does. So there's nothing I can do now. But I can pause the program with Control Z. Okay, and it stops sleep. So sleep is in the background. I'm going to type jobs, and you can see that it's stopped. So if I type foreground or foreground 1 at this point, sleep comes back to the foreground. To terminate a job that's in process, that's active on your screen, you can do Control C. Control C will cancel or break out of that process and terminate it. So that's what jobs and foreground and Control Z do. Now let's look at niceness. So let's start sleep again. Okay, and let's type PS minus L. PS minus L shows me the priority and the niceness for sleep right here. So notice that the niceness is 0. So I'm going to do a kill all on sleep. So by default, the niceness was 0. So if I do nice sleep 10,000, I'm going to do Control Z to put that in the background, and PS minus L. I can see here the niceness is 10. So sleep actually lowered the niceness priority down to 10. And you can see before the priority here was 76, and now the priority is 86. So it actually has a lower priority. 10 is lower than 0. Don't forget that. So let's do a kill. Okay, now sleep is running. So let's change the priority or the niceness for sleep. So I'm going to renice minus 10, and then the process ID, 3039. Okay, it told me the old priority was 10, the new priority is negative 10. So let's do a PS minus L, and now you can see the new priority is negative 10, or the new niceness is negative 10, and the priority is 70. So that made it higher priority because it's negative 10. The niceness is negative 10. So you can kind of see how nice and renice works. We also saw how PS minus L shows you the niceness and the priority. So that's basic processing, how to kill processes, view different processes, put jobs in the foreground, background, and give greater priority to processes. We also saw how init is the root of all the processes in the process tree. Any process that starts with K is a kernel process, and how you shouldn't, kill those processes, but you should be aware that they're out there, and just basically that they're important system processes, and how you should kill those through, or stop or start those through, like the services program. And we'll be showing you the services program a little bit later. So with that, let's exit out of this and let's go back to our slides. So let's move on. And now we can talk about monitor and troubleshoot network activity. Alright, Linux Plus Objective 2.14 says you should be able to monitor and troubleshoot network activity, for example using ping, netstat, and traceroute. So we're going to examine those commands and a few others in this portion of the video. First off, let's talk about ifconfig or interface config. This shows network interfaces. It can also be used to reconfigure those network interfaces from the command line. So think of ifconfig as like ipconfig in Windows. It shows you what the current status is of your network interfaces. ifconfig also gives you some statistics. And it can also be used to reconfigure the interfaces, whereas ipconfig in Windows cannot. The graphical tool to reconfigure network interfaces and show what their IP configuration is now is system-config-network. This is a Red Hat tool. This isn't available on all Linux systems. Now ping does a network continuity test. So that just means it sends a ping packet, an ICMP packet from this computer across the network to whatever device you're pinging. That device responds and the ping comes back. So ping comes from like submarines where they would ping using sonar to look for other ships or submarines out there in the ocean. So ping does a network continuity test. Now in Linux, ping goes forever until you press Control-C to stop it. In Windows, if you type ping in a network address, it pings 5 times and then it stops. In Linux, it'll just keep on pinging forever. So to new users, that can be a little bit frustrating who are used to how Windows works. So in Linux, just type ping the network address, and when you're done pinging, you press Control-C to break out. You can also go in and specify the number of pings you want it to be performed with a command line switch. Another important program is netstat. Netstat by default shows active network connections and sockets. So you can see what's going on in the system that's using the network. What processes are using the network and where are they connected to. But netstat also has a lot of different options. Netstat -R shows the routing table. Netstat -S shows networking statistics. Another program is traceroute. Traceroute traces the route that traffic takes through a network and provides statistics for each hop along the way. So we're going to try out traceroute. You can see exactly how it works. A network is made up of multiple networks connected together. So think of the internet. There's my network here connected to my internet service provider, and that internet service provider is connected to someone else, say AT&T, and AT&T is connected to SBC, and then maybe your network connection is off of SBC, and then there's your network, and then you have a remote site connected to that network, and there's a subnet between your site and that remote site, and then the remote site has a local LAN. So you see how all these networks are just connected together. Well, traceroute will show you the route that traffic takes from one network to another, and what networks it goes through in between, and what the performance is for each of those different networks. So if you're having a problem where, say you're connecting to a certain website on the internet and it's running slow, well, you can do a traceroute and you can try to determine what network along the path to the network that's running slow is actually the problem. Because it isn't always the end network that's the problem. Many times it's a network in between that's actually causing something to run slow on a network that you're trying to get to. So let's give these a try. Let's see how these work. So over here on our live Linux system, I'm going to open a terminal window. And let's just start off with ifconfig or interface config. ifconfig by default just shows you the interfaces on the system. First one is Ethernet 0. That's the name of our Ethernet interface on this system. Shows you that it's an Ethernet interface. Here's the MAC address, or the hardware address. That's the MAC address that uniquely identifies this Ethernet adapter at layer 2 Ethernet. Shows you the IP address of this Ethernet adapter, broadcast address, subnet mask. Shows you that it's up, it's running, that's important, it's received 8,237 packets, and it's transmitted 11,187 packets. 0 collisions, it's received 3.8 megabytes, transmitted 2.7 megabytes. So that tells you the status of your Ethernet interface. Of course, every system has a loopback interface, which is the local loopback interface usually for troubleshooting. So that's ifconfig, and it can also be used to reconfigure this interface. You can use it to change the IP address, shut down the interface, bring up the interface, whatever it is you want to do to reconfigure that interface. So ifconfig, the Linux command, the Linux equivalent of ipconfig that shows you your network interface status. So now let's use a system config network. If you go to System, Administration, and then to Network. This is the graphical tool that's used to show the status and reconfigure your network interfaces. So here is our Ethernet interface, the same Ethernet interface we saw over here at the command line. I can deactivate, which is shut down this interface. It's the equivalent of if down, if you can see that right there on the description, if down space ETH0. So it's the same command at the command line, but here you just click a button. Then here's activate, which is the same as if up ETH0. That's another command used to bring up the interface. So if I double click on this, here I can rename the interface, I can set it to use DHCP, or I can statically set the IP address right here. I can enter a static route in my routing table, and I can see the status of the hardware. I can change the MAC address here if I wanted to. I'm going to say cancel because I don't want to do any of those things right now. And let's go into hardware. Here you can see what hardware I have on the system and the status of that. If I double click it, I can change some settings here like IRQ, IO, DMA addresses, stuff like that. Hopefully you don't have to change any of that stuff, but that's where you go to change it. Here I can click on IPsec, and I can configure IPsec tunnels to other hosts out on the network. These are encrypted tunnels over a network. So by default, traffic isn't sent in any sort of encryption, and people can sniff that traffic or see that traffic out on the network, and they might be able to use it against you. So with IPsec, you encrypt all traffic between your host and another host to make sure that that traffic's secure. So that's what IPsec is, and this is where you can configure IPsec tunnels. Here's the DNS tab. So this is where you configure the host name and the domain name of this system, as well as the DNS IP addresses and the DNS search path. So let's click on hosts here, and on the host tab you can see that you have static computer host names to IP address mappings here. So if you're using DNS, you probably don't have to configure any of this. DNS is going to take precedence over the static host name mappings. But if you only had a couple hosts on your network and you didn't want to mess with DNS, you could use the host mapping file here. And this configuration here really is just editing the etc hosts file. So in the etc directory there's a file called hosts, and this is just editing that file. So this is the system config network utility that's offered by Red Hat Linux or Fedora Linux. So let me close this out. And we'll go back here to our command line. Now let's try out ping. We talked about ping, how it does a network continuity test. I'm going to clear the screen and type ping www.trainsignal.com. Let's pretend that we're having trouble talking to the Train Signal website. We want to see if we can communicate with them at all with a ping command. You know, say your web browser isn't working. Let's try out ping. So I press enter there and it immediately does a DNS lookup. That's what this is right here. You can tell it was able to do a DNS lookup because here's the IP address and here's the domain name. So you know that DNS is working at this point. And then it starts transmitting data. So it sends 64 bytes to this IP address, and it got a response back in 48.4 milliseconds. So that's a really fast response. So you can see it has sequence numbers here, it keeps on counting, and it just keeps on pinging forever. So that's how Linux ping works. If I press Control-C, it stops pinging, and it gives me statistics, some sort of summary statistics. So it says that 41 packets were transmitted, 41 packets were received, there was 0% packet loss, so no packets were lost, and that's how many milliseconds it went for. Here's the round trip time minimum, so the minimum amount to transmit and receive a response back was 33 milliseconds. The average was 52 milliseconds, and the worst transmission time was 94 milliseconds. So that's what ping does. It does network continuity testing. Sends out a packet and gets a response back. So now let's look at netstat. So I'm just going to type netstat and press enter. And you can see we got a lot of information there. Let me type netstat, pipe that to more. So by default, netstat tells you your active internet connections. That's this section here. So if you have something run on your system that's using the network, you want to find out what it is and where it's going, this is the place you could go to. It also tells you the active Unix domain sockets. So these are other types of network connections on your server. So if I scroll through here, you see all these different domain sockets. I don't use netstat just by itself a lot, but what I really like is netstat -r. This is the routing table. So this tells you my default network here is this 192.168.1.0 network. And then if I don't have any traffic, or if the traffic that I'm trying to send to isn't going to this network, I have a default route. The default route is this line right here. It says default is the destination. And here's my default gateway, 192.168.1.0. You can see these are both connected to Ethernet interface 0. And when we looked at the system config network, you saw in there where you could add or remove routes. If you did that, they would show up on this IP routing table. Another nice statistical program is netstat -s. I'm going to pipe that to more also. So you can see here, this gives me network statistics for the server since it was booted. So here's IP statistics. I've sent a total of 28,843 packets. None of those were discarded. ICMP, I've sent 1,038. I've received that many, I'm sorry. None have failed. I got 3 destination unreachables, 3 echo requests, 960 echo replies. For TCP, I have 125 active connection openings. Lots of statistics on here. You have to read the man page really to learn more about exactly what these some of these statistics mean. But there's UDP statistics and other TCP statistics down here. So that's netstat -s. Let me clear the screen, and now let's use traceroute. So traceroute sends out packets first to my closest default route, and then to my ISP, and then every piece of equipment along the path in my ISP's connection, and then it just basically it goes through the internet and it goes to the server that I tell it to go to until it can't, do anything else. So along the way, it sends 3 ping packets or 3 traceroute packets to each of the different hops. So it started off with my default gateway right here, 192.168.1.1. It sent 3 packets to that to test the response time. It got a response of 1.7 milliseconds, 1.8, and 1.3. So that's pretty darn fast. Then from there it goes to my internet service provider along multiple hops there, and you can see the latency there. And then it gets to one that it can actually do a DNS lookup on. These names or numbers here on the left tell you whether or not it could do a DNS lookup. If there's a number, it couldn't do a DNS lookup. If there's a name, you know it was able to do a DNS lookup, because here's the IP address over here and here's the name on the left. So this is most likely Dallas, Texas, and this is the AT&T network. So this is an AT&T Dallas, Texas network device. Then it went to another one here. I'm guessing maybe this is St. Louis, Missouri. I'm not sure though. And then another one that says WDC. Maybe that's Washington, D.C. I'm not sure. But you can see here it's going through these different hops in the AT&T network. And I always find it interesting to do trace routes, around the world and see all the different cities that the trace route takes you through. Then it gets to some other network devices, and finally it gets to this rackspace.com. And you can see here it's even going through VLAN 903. It's amazing all the information you can get out of this. Then to another Rackspace destination before it finally fails. And don't be too concerned with the failures here, because not all network devices are configured to provide a traceroute response. But if you do get really high, traceroute times over here, you might want to be concerned, because that might be the cause of your problem. That network device or that company's network might be where the slowness is coming from if you're having trouble and using traceroute to configure or to troubleshoot, some sort of network slowness. So that's the traceroute command. I'm going to close out of this. So let's go back to our slides here, and let's talk about our next topic. So now let's talk about manipulating text files in Linux. Linux Plus Objective 2.15 says perform text manipulation, and it gives examples of 3 programs: sed, awk, and vi or vi. Now sed stands for Stream Editor, and the awk program is based on the names of the people who created it. Mr. Aho, Weinberg, and Kernighan, AWK, is where the name came from. Sed and awk are frequently used together to edit text files. There is a GNU version of awk called gawk that's available on some Linux systems. There are entire books on sed and awk. These are very complicated programs. An example of one book is the O'Reilly Sed and Awk book, 2nd edition. And here's the URL for that in case you're interested. Here's a basic sed command just so you can see what it does. This says sed, and there's an S for search and replace, and you're replacing 2005 with 2006. So you're not changing the names of these files over here, but what you're doing is taking this file, and every occurrence of 2005, you're replacing it with 2006 inside the file. So say you had a lot of dates in that file and you wanted to change them from 2005 to 2006. It would go through this file, look for every 2005, replace it with 2006, and then send the output to this text file. And we're going to do this command here in just a second. Now here's a basic awk command. Awk works off little command strings inside this area here, these single quotes and brackets. So this says print $1. $1 would be the first positional parameter in whatever file you tell it or whatever stream of text you give it. So if you use that example on the etc password file, you cat etc password, pipe that to awk. The positional parameter in etc password, the very first one, is the username. So here you're saying print the username, and then the field delimiter is the colon. Every field in Etsy password is separated by a colon. So this would print out the username, all the users on the system, in one command. And then I could send that to a text file, and I could do whatever I want to do with it. So that's just an example of how to use awk. And we're going to do that command here in just a minute. But first let's talk about Vi, or VI. VI was the very first full-screen editor for Unix. It's very basic, it's very small, it's very simple, it's only a text-based program. It's required to be used in the emergency recovery of Linux, so you must know how to use it. And besides that, it's just a good text editor to use on Linux. Now it's difficult to learn, but once you learn it, it's very handy to use. VI has 3 modes. They are Command, EX, and Edit. Command mode is where you type commands for VI to do something, like search and replace text. EX is the actual screen mode where you're looking at the text and you're scrolling up and down through it. And then Edit mode is where you're actually changing the text. So to go into command mode, you press colon. To get out, you press escape. You can use arrow keys or the equivalent letter keys for movement in EX mode. So that's to go up and down through the text, or left and right. There are equivalent letters that represent each arrow key, up, down, left, and right. To enter edit mode, you can press R for replace, A for append, or I for insert. So these are 3 different ways to replace, to append to, or to insert text. You can't just start typing. This isn't Microsoft Word. You can't just start typing on things. You have to select one of these different edit modes. To exit the edit mode, you press escape. To search in command mode, type the / and I'll show you how that works. To do a global search and replace, type %s/ the text you want to replace with the new text, and then a G for global for all occurrences. And we'll do that. Now an extensive VI reference guide can be found at this website here, and it's many pages long. Another good VI website is vim.org. So let's try out these 3 different utilities and see how they work. So first off, we're going to try out sed. Now in my home directory here, I created this file called 2005.txt, and we're going to use that sed command we saw to create a new 2006 file. But first let's look at what's inside this file. I just put some dates in here. June 2005, April 1st, 2005. All of them have 2005. So let's say I want to replace these 2005s with 2006. And you might be thinking, well, why not just edit the file? I mean, it's only 4 lines long. Well, pretend that this file is 10,000 lines long. You want to very quickly replace 10,000 entries and change them from one number to another number. So to do that, I'm going to use sed. I have to put a / here at the end, like that. I'm going to give it the text file name. And I could just redirect that to the screen. Let's see what that looks like. So that's what it's going to look like. It just sent the output to the screen. If I hit up arrow, I can redirect that output to a new file called 2006.txt. So it just created me a new file, and I can cat out 2006.txt, and notice it has the exact same output that it sent to the screen just a second ago. So that's sed. I made it look pretty easy, but really it's a complicated program to learn how to use. You can do man space sed, and you can read all about it, or you could even go buy one of those books at the bookstore. So you can use awk with sed. We're going to use awk just by itself now. So if I cat out the Etsy password file, shows you all the users on the system. And notice the very first column is the username right here. Then there's a colon, then another field, then a colon, then another field. So if I cat etc password and I pipe that to awk, and I tell it that the field delimiter, capital F, is a colon, then I put in the single quote, the little squiggly bracket, and I say print $1. Close that out. Press enter. It gives me a list of all the users on the system because that's the very first field. So that's a quick way to get every user on the system. And let me show you another little trick. I can pipe that to word count. Word count is a program that gives you a count of the number of lines that are sent to it. So I've got 40 users on this system. Very quick way to get the number of users configured on the system. Now the interesting thing is I've only added 3 users to this system, David, S. Jones, and F. Smith. So there's 3 users added, but yet there's 40 configured. So by default, that means that Linux has 37 users already created by default for system purposes. These are all system users, 37 users. Now if I cat out etc password again, you can see the comment field right here is S. Jones. Say I wanted the comment field for everyone. Well, what positional parameter would that be? Let's see, 1, 2, 3, 4, 5. That's the 5th positional parameter. So if I change my command line here to 5, I get the comment for every user on the system. Now not every user has a comment, so there's a lot of spaces here. But you can see there's Sally Jones and Fred Smith, the 2 users that we created. So that's how you use awk. So let me clear the screen and let's use vi or vi. So say I say vi/etc/password. Okay, I opened up the etc password file in vi. I can use my arrow keys here to scroll down, scroll right, left, or up. Okay, right now I'm in EX mode. I can't just start typing and edit this text. This isn't Notepad or Word. It doesn't work like that. But let me scroll down to the bottom. And let's look at this user David right here. I'm going to take the David user and say I want to replace his username, or let's say I want to add a comment. Right now he doesn't have a comment, and that's something every user should have. So say I want to insert a comment right there. I have to press I to insert text, and I can just start typing. Now see, I'm in insert mode down here. See this insert? That tells me I'm in insert mode. To get back to EX mode, I press escape. So I used insert mode to insert that text. Say I want to replace some text. Right here. To replace that text, I push capital R for replace, and now I'm in replace mode. So I type the things I want to replace, but I can't just hit backspace and delete that space right there. I have to hit escape, and then there's EX mode keys too. So say I want to delete that space, I can hit X to delete that space, and that's how you have to delete things. It's very strange sometimes. Now say I want to do a search and replace for every David in this file. So if I do colon, I'm put in command mode. That's command mode down there. So to do a search and replace, I'm going to do %s, the thing I want to replace, or the thing I want to search for, with the thing I want to replace. And then a /g will do a global search and replace. So if I press enter right there, notice what happened. The David was changed to Davis. Just that quick. So it's not a big deal if there's just one, but if you had a file again with 10,000 entries you wanted to search and replace, that's a very quick way to do it. So to exit without quitting, I press colon And down here in command mode is where you tell it if you want to save this or not. So to just quit without saving, you type Q to quit. To write and quit, which would be save this file, you do QW or WQ. Would write the file and then quit. I don't want to write over this file. I'm just going to hit Q for quit. Okay, and it tells me no write since last change. So I haven't saved this file. So it won't let me quit without saving, because then the changes would be lost. But to override that, I do Q exclamation point to override. And I quit without saving. So that's how VI works. It'll take some time to learn, but I suggest you go out to the website vim.org, read about VI, learn about it, use the man page, man space VI, and just practice on some text files that you create yourself. Don't practice on the password file. That was just an example file. Create your own copy of the password. You can do that in your own home directory and edit it and change it all you want with VI. So we just learned how to manipulate text using sed, awk, and VI. Now let's talk about redirecting output. Linux Plus Objective 2.23 says you should know how to redirect output, for example, piping and using redirection. Now, a pipe connects two programs, and I know we've already talked about piping and redirection, but I just want to go over it one more time here to make sure you fully understand. A pipe connects two programs, so the output of one program is sent to the other. So an example is you cat etc password and you pipe that to grep for something you're looking for. That's what piping is, and we're going to try this again in just a second. Now, a greater than symbol sends standard output to something else. So you can cat etc password and you can redirect the output to another file. That's what we're doing here. You can also chain commands or list things together using a semicolon. So say I want to do two commands in succession or multiple commands. I can do cd/s, so I change directory to etc and then do an ls-l. So in one command line I performed two commands. So let's try these things out. So first off, let's try piping. We did ps minus ef, and then we can grep for init. So we just found the init process. We can cat etc password, and we can grep for David. So we just found the user David. You can do, there's just an unlimited number of combinations you can create using pipe to pipe output from one program to another program. You can also use redirection, of course, and we just did that a little bit with some other commands. Right now, let's try cat etc password, and let's make a backup of it using the redirection symbol or the greater than. So I'm going to redirect that to /root/password backup. And if I do an ls-l, you can see here's a password backup created right there. So I did that with redirection. Of course, I could have also used the copy command or CP. But redirection is used for a lot of different things. So now let's try chaining or listing commands. So if I do cd/etc, then I put a semicolon, and I do ls, and then I put a semicolon, and then I do cd $home, and then a semicolon, and then ls. So I'm going to change directory to to etc. I'm going to list out the files. I'm going to change back to my home directory, and then I'm going to list out the files again. So if I press the button, it just did all that in one command. So I changed directory to etc. It doesn't show any output for that, of course. I list out the files in etc. Then I change back to my home directory. Then I list out the files in my home directory. These files are in my home directory. These files are in etc. So a lot of different things you can do, like ps semicolon ls. So I just did a process list, and then I listed out the files in my home directory all in one command. So pretty cool way to speed up your command line input and just make things a little bit faster and easier. Alright, we learned a little bit about redirection and standard output and piping and chaining commands together. So with that, let's go on to our next slide, which is the conclusion. So in this video, video number 7, we learned how to manage Linux processes. We learned about the PS command and how it shows you the process status. We learned about PS-F to show you the full status. PS-E shows you every process on the system. PS-L shows you the niceness of the processes on the system. We learned how to kill processes using the PID number with the kill command, and kill all using the name of the process. We learned how to nice processes when you start them and re-nice processes after you start them. We learned about the jobs command to show you what jobs are in the background and how you can use the foreground command to put jobs in the background into the foreground, and how Control-Z will suspend a job and stop that job from processing. We learned how to identify processes by using PS-E. We saw the init process, and we saw all the kernel processes that start with K. You learned about how you don't want to kill those processes because you can bring down your whole system or cause something seriously bad to happen to your system. We learned about PS-EFH, capital H, which shows you the process tree. It's a very handy command. We learned how to troubleshoot and monitor network activity using ping, traceroute, and netstat. We learned how the ifconfig command shows you the status of your network interface, and it can also be used to modify your network interface, unlike the ipconfig command in Windows. We learned how to manipulate text files using sed, the stream editor, awk, and vi, the text editor. Finally, we learned how to redirect output using piping and redirection. So with that, that's the end of video number 7. This has been Administering Linux Part 1. Thank you very much.